Alright, so I'm going to use the rational laws. Right, so the first thing is to remove the square root sign or the radical sign. So if I want to remove it, I can write that numerator as 3 to the power of 6x minus 9 all over 3. Please take note that I can also write this as 6x minus 9 in brackets times 1 over 3. Okay, it's also the same. So this is times 27 to the power of 3x all over 3. Now this is all over. Now the denominator, okay, since you are in grade 11 now, I'm going to simplify it straight away. So this is the same as 3 to the power of 4x minus 2. And that will be 3 times 3 to the power of x. Okay. I hope nobody gets confused as to how I got this 4x minus 2. I converted 9 to a base of 2. So it becomes, to a base of 3, it becomes 3 squared. So 2 times 2x gives me 4x, 2 times minus 1 will give me negative 2. Alright? Then, let's simplify that. So I'll get 3 to the power of 2x minus 3 times 3 to the power of 3x. Because 27 is the same as 3 cubed. 3x over 3 gives me x. So from that 3 cubed, the exponent is going to be 3 times the x. I'll get that 3 to the power of 3x. So this will be 3 to the power of 4x minus 2 times 3 to the power of x. Okay. Is there anybody who has got a question there? Yes.
So from last step when you got the 2x minus 3, why did you get 2x?
6x minus divided by 3.
Oh,
Then 9 divided by 3 will give you this 3. The negative and that negative, you just put them there. Okay, remember, your knowledge of algebraic fractions is also important. And you did algebraic fractions in grade what? 9. You also did algebraic fractions last year. So you've done algebraic fractions for 2 years. Right? Then from here now, I can now apply the first law of exponent together with the second law of exponents combined. The base is now the same throughout. Okay? Since the base is the same throughout, if the bases are multiplying each other, you add the exponents. If they are dividing, you subtract the exponents. Okay? So this will be 3 to the power of 2x minus 3 plus 3x minus, now this is a binomial exponent. This is a binomial exponent. Therefore, I have to put it in brackets. So, this will be minus 4x minus 2 minus x. As long as an exponent is part of the denominator, you subtract it based on law 2 of exponents. Okay? Then from here now, I can just then simplify. So 2x plus 3x will give me 5x. 5x minus 4x will give me x. X minus x will give me 0. Then minus 3 minus minus 2, that will give me negative 1. So I'll end up having 3 to the power of minus 1. My final answer is going to be 1 over 3. So that's the final answer. So if you did the question, mark your work. You're supposed to get 1 over 3 is the final answer. Okay, please take note that everything I wrote here, it was just to refresh you in terms of the rational law. Okay. Is there anybody who has got a question before I carry on? If you don't have a question, then let's get on. Then I gave you that one there. Please, when you get a question in maths, sometimes you can get scared, but there's no need to be scared. Every question has got a specific concept that you have to use in order to solve that specific question. Okay? So, because we have got square roots there, we have got non-prime bases. It means we need to eliminate the square root sign. We also need to convert all non-prime bases to prime. Okay? So, first thing, I'm going to remove the square root sign first. So I'm going to write that as 8 to the power of x minus 2 all over 2 times 9 to the power of x over 3. This is all over the denominator, that will be 6 to the power of 2x minus 9 over 3 times 2 to the power of minus x over 6. Okay, so I've removed the square root sign first. Then the next step is to simplify those exponents that are in fraction form. Okay, if they are algebraic fractions, then I have to simplify them. And also convert the bases to prime. So this 8 is going to be 2 cubed. Right? That will give me x over 2 minus 1. Okay? Times 3 squared, all raised to the power of x over 3. This is all over the denominator. I'm going to have 3 times 2 raised to the power of 2 over 3x minus 3. Please be aware that your knowledge of fractions is very, very important now, more than last year. Because when you are dealing with some questions on exponents, you have to be a master of working with algebraic fractions. So from here, I've got that. This one is already simplified, so that would be times 2 to the power of minus x over 6. Then, when I remove the brackets, okay, so here, I'm going to have 3 times x over 2, that will give me 2 to the power of 3x over 2 minus 3. Right? That will be times 3 to the power of 2x over 3. This is all over. Okay, here I've got 2 different prime bases, okay, inside the bracket. So this 3 here is going to have that as its exponent. So that will be 3 to the power of 2 over 3x minus 3 times 2 to the power of 2 over 3x minus 3 times 2 to the power of minus x over 6. Okay? Please be aware that sometimes when you see me writing, if I write, well, this is important for you to know. If I write 2 over 3 times x, if I write 2 over 3 times x, please be aware that this is the same as 2x over what? 3. It's the same. Okay, so you mustn't get confused there. 2 over 3 times x is the same as 2x over 3. Okay, so from there, now I can use law 1 and law 2. So in the end, you have to apply your law 1, your law 2. Okay, so let's start with terms with a base of 2. So that will be 2 to the power of 3x over 2 minus 3. Now this one here is a negative exponent, so we end up having minus x over 6 based on law 2 of exponents. If you are dividing bases that are the same, you subtract the exponents. Then I don't have space. Okay, I also have this one there. Okay, so I was supposed to write this binomial one first, but it's fine. I'm going to put minus. Then I'll open my bracket, 2 over 3x minus 3 times this. I don't have space, so I'm going to write it down. But in your case, in your book, you have to write in a horizontal direction. So that would be 3 to the power of 2x over 3. Or let me write it as a common fraction, the normal way. 2 over 3x Okay? This one here, minus, open bracket, 2 over 3x minus 3. That's where I am now. Okay, now let's simplify. Let's start with the base of 2. So we have this 3 over 2x. Okay, allow me to just write it like the second one to avoid issues. So let me just erase that. So that will be 2 over 3x, like that. Do you agree with me that this 3 over 2 times x and that one will cancel out? Do you see that? They are going to cancel out. Right? Then I'm going to be left, if there's a minus here, times this minus, you get a what? A positive. So, you end up getting 2 to the power of x over 6. Then minus 3 minus minus 3. That will give me a what? A 0. Okay, so this negative 3 and that negative 3 are going to cancel out because we have a minus. Please, if you have got a question, feel free to ask. Yes?
So with the 3 over 2x and 2 over 3x.
Oh, okay, sorry, I made a mistake. I'm so sorry for that. Sorry. Thank you for that. Sorry, I made a mistake. My sincere apologies there. This is 3 over 2x, and that's 2 over 3x. They can't cancel out. Sorry. Let me correct myself there. Sorry for that. It shows that people are following. Alright, so 3 over 2x minus 2 over 3x. You see that the denominator is not the same here. So they can cancel out. Okay, I'm sorry for that mistake. So I have to convert this 2 here to a denominator of 6, that one to a denominator of 6. So, to avoid unnecessary silly mistakes, I have to multiply that 3 there by what? By 3. So I'll end up getting 9. Then that will be 9 over what? 6. Then here we have got minus x over 6. Then that one there becomes minus 4 over 6x. Then minus 3 minus 3, that will give me what? A 0, isn't it? Yes? Okay, can you speak up?
Doesn't the minus go into the minus x over 6 minus?
Which minus? Which minus? Oh, that one. Okay. That's a plus. Okay, minus 3 minus 3 give me a 0, right? Then 3 over 2x becomes 9x over 6. Then we have got a minus here, and that minus becomes a plus. Yes. Then we have got this minus here. It remains a minus. Okay, so it's fine now, isn't it? Huh? Is it okay now? Yes. All right. Okay, so from here now, we need to multiply now the base of 3. So we have got 3. Now these two have the same denominator. Okay, so we have got 2 over 3, there's 2 over 3, so these two will cancel out. So this minus and that minus will give us what? A positive. So we end up having 3 cubed. Right? Then let's simplify those terms in x. So this one will be 10 minus 4x, that will give me 6x. So eventually I'll get 2 to the power of what? 1 times 3 cubed. And this answer will be 27. Okay, 9x, that gives me 10x. 10x minus 4x. Okay, so this will be x. So eventually my answer will be 27x. Sorry? Okay, I'm so sorry. I don't know why today I'm making this mistake. Okay, wait. 9x plus x, that will give us 10x. Then you get 6x. So you end up getting 2 times 6x over 6 times 2 cubed. Alright, okay, so this will be 3 cubed. Okay, that will be 3 cubed. So eventually the final answer will be 2 to the power of x times 27. Okay, I have to apologize once again. Okay, my brain is not in a very good shape. Yeah, it's wandering around. Okay. Right, is there anybody who has got any questions so that we can clarify whatever issues you might have? Huh? How many of you got that as the answer? Right, so if you didn't get 2 to the power of x times 27, okay, please just write the corrections. All right. So we're going to simplify exponential expressions involving addition and subtraction. Now, if you want to simplify an exponential expression like this, which has got subtraction there, you need to know that you have to factorize along the way. So if you are to factorize, it means you have to create the common factor first. Okay? And also make sure that all your bases are prime bases. Okay? So the first thing that I'm going to do is to convert. Okay, that 4 don't make a difference. I also need you to be aware that based on law 1, a to the power of m times a to the power of n, this is equal to a to the power of m plus n, based on law 1 of exponents. Now, if you've got an exponential expression which has got subtraction of terms, you need to use the first law of exponents by moving from the right-hand side towards the left-hand side. So you'll be moving in that direction. Okay? So far we have been moving from left to right. Now we are going to do the opposite. Okay? Alright? So, remember, you have to use the first law, moving from the right-hand side towards the left-hand side. You also have to identify a common factor, and then you factorize. So I'm going to break up this 3 to the power of x plus 1 to 3 to the power of x times 3 to the power of what? Of 1. I've used the first law of exponents by moving from right to left, minus, now in this case here, converting the 4 to a base of 2 won't make a big difference. Okay? It's not necessary for this question. So I'm going to leave it as it is. Okay? Times 3 to the power of x times 3 to the power of minus 1. All over 3 to the power of x times 3 to the power of minus 2. So I'm applying law 1, moving from the right-hand side towards the left-hand side. Okay, so I said if you are simplifying exponential expressions involving addition and subtraction, first you have to use the first law of exponents by moving from its right-hand side towards the left-hand side so that you can be able to create the common factor. Yes?
What do you mean by moving from the right to the left?
Okay. You see that your basic first law is that, right? Your left-hand side, we have got a to the power of m times a to the power of n. The right-hand side, it has got a to the power of m plus n. So when I say you are moving from right to left, it means you are moving from this form which has got a to the power of m plus n to its broken form which is on the left hand side, which is a to the power of m times a to the power of n. You understand that? Right. So 3 to the power of x plus 1, based on the fact that we are moving from the right hand side of the first law towards the left hand side, it will become 3 to the power of x times 3 to the power of 1. Then, and then 4 times 3 to the power of x minus 1, the 4 remains as is. Okay, there's no need to convert it to a base of 2. Then 3 to the power of x minus 1, it will be equal to 3 to the power of x times 3 to the power of minus 1. I'm using law 1, moving from the right hand side of law 1 towards the left hand side. The denominator, 3 to the power of x minus 2 becomes 3 to the power of x times 3 to the power of negative 2. All right? Now, by observation, do you see any common factor in the numerator? What is that common factor? It is 3 to the power of x. Please, it's not 3x. Please, it's not 3x. Right? 3 to the power of x is not equal to 3x. Okay? It's 3 to the power of x. So our common factor here is that. That's our common factor. So I'm going to take out that common factor. So we are back to factorization now. But you are in grade 11, so this should not be unusual. So we get 3. So we get 3 to the power of x, and you open the bracket, 3 to the power of 1 minus 4 times 3 to the power of minus 1. This is all over 3 to the power of x times 3 to the power of minus 2. All right? Now, this is a common factor. So those two can cancel out. Was they appear in both the numerator and what? The denominator. Then, I'll be left with that numerator. So this will be 3 minus 4. This becomes 3. So we'll have 3 minus, if I want to simplify this, 4 times 3 to the power of minus 1, it will become 4 over 3. This is all over 2 to the power of minus 2. That will be 1 over 4.
It's 3 to the power minus 2.
Is it a 3?
Yes.
Okay, so that becomes 1 over 9. Okay, I saw it as a 2. Sorry for that. Okay, so if you look at it like this, looks like a 2. I needed to go down there. Okay, so it will be 1 over 9. Right, any question there? Okay, I'm aware that working with fractions can be a bit of a challenge, but fractions are not that challenging. Okay, so let's simplify the numerator. If I want to simplify the numerator, please be aware that the denominator of that 3 is a 1. So, the LCD of 1 and 3 is a what? 3. So we end up getting 9. So we end up getting 9 minus 4 over 3. Okay? That's our new numerator now. Now, it's always better to convert a division line to what? To a division sign when you're working with fractions. Okay? Because it's not wise to have so many division lines. So in this case here, this is our main division line or our major division line. I'm going to convert it to a division sign. So I'll put here divided by, let me write that properly. So that becomes divided by 1 over 9. Okay, just to remind you, when you are doing a question like this, no calculator is allowed. So you have to show all your what? Your working out. No calculator is allowed. If you use the calculator, you can be penalized. So 9 minus 4 will give me what? 5. So I'll end up having 5 over 3. Then I'll convert this division sign to what? Multiplication. Once I do that, I'll end up having times 9 over 1. So my final answer is going to be 15. Are you following that? You have to know how to work with fractions. You have to know how to work with fractions. I started going over these two questions. Please be aware that there is nothing wrong with you getting an incorrect answer. Okay? Because I'll go over it. What's important is you learn from the mistakes you made.
Yes.
Okay? Don't be ashamed of getting an incorrect answer. Alright? Okay, so number 4, the first thing, since we have a square root sign in the first term of the numerator, we remove that square root sign first. Okay? So, this will be equal to 16 to the power of x over 2. Right? Minus, please allow me to break the second term based on the first law, moving from right to left. Can you pay attention, please, and look here? So this will be 2 to the power of 2x times 2 to the power of minus 1. All over. The denominator, I can write this 2 to the power of 2x. Okay? Are you following that? Right? Then the next step is to convert the 16 to a base of 2. So this becomes 2 to the power of 4. Okay, I'm not going to skip any step because I want to make sure that everybody is clear about what's happening. So that will be 2 to the power of 2x times 2 to the power of minus 1 all over 2 to the power of 2x. Okay? Please check your work. As I write down these steps here, use a pencil to put a tick so that you'll be able to identify where you might have made a what? A mistake. So this one here to that. Then from here, we remove the brackets. If I remove the brackets, I'll get 2. Now here, 4 times x over 2 is going to give me 2x. Okay? So this becomes 2 to the power of 2x minus 2 to the power of 2x times 2 to the power of minus 1. All over 2 to the power of what? 2x. Now in the numerator, what's the common factor? Yes?
So since the square, aren't you also supposed to square the 2?
Sorry?
Aren't you also supposed to square the 2 in the denominator? Like,
No. No. Okay. It's a good question. I hope if you go back to the laws, right? This is very important. Let's go back to the laws. Okay, it's important for us to go back to the laws. Right, remember last week I told you that you need to what? Last week I told you go over your what? Exponential laws. Now one of the exponential laws that you are supposed to know is this one here. Okay, let me try to highlight it. Right? This is the exponential law. A to the power of n, or raised to the power of n. Okay? Please, this is equal to a to the power of m times n. It's not equal to a to the power of n times mn, or whichever way you want to write it. Okay? So you just multiply the exponents according to this law. You multiply the exponents. The base is not affected. Alright? It's a very common mistake. The base is not affected. You just multiply the what? The exponents. Alright? Also, if I give you 2 to the power of x all squared like this, do you know that it's also equal to 2 to the power of x times 2 to the power of x? Am I right? Huh? Now, if you are multiplying two exponential terms that have the same base, what do you do to the exponent? Add. So you end up getting 2 to the power of what? 2x. Okay. Is that okay now? No. So make sure you avoid that mistake. Okay. Let's carry on. Thank you so much for asking that, because that's a very common mistake. All right, let's carry on. So from there, from here, we've got our 2 to the power of 2x. Then we identify our common factor, which is 2 to the power of 2x. Now, I'm not sure whether you know this. How do you get the first term of the binomial factor inside brackets? Is there anybody who can explain to us? If we go back to the basics of mathematics, I'm talking about the basics of mathematics. How do you get the first term of the binomial factor inside brackets? I need someone to explain to us. How do you get the first term of that binomial factor inside brackets? Tell us from the basics. Let's say you were to meet someone in the street and they have never done exponents. How would you explain it to them? Okay, then you wanna try? I'm saying, remember, we are gonna write an answer here. Let's say the answer is y. Here. How do you get that answer from the previous step? Huh? I'm just giving you an example. If it was y, how would you get y? What do you divide? Yes, Sean? Okay, can you be quiet, please? Can you be quiet? Yes?
To find the first part of the bracket, you have to divide the first term of the binomial by the highest common factor. No. Yeah. Yes. No.
But some of the things you said, they do make sense. Like, boys and girls, it's important for you to know going forward that to get the first term of the binomial factor, you divide the first term of the numerator of the original expression by your common factor. Remember, we've identified our common factor as 2 to the power of what? 2x. So if I want to get the first term here, it means I have to divide 2 to the power of 2x by the common factor 2 to the power of 2x. And my answer will be what? 1. Then how do you get the second one? How do you get the second term of the binomial factor? You divide the second term, okay, of the original expression, of the numerator of the original expression by the common factor. So if you divide 2 to the power of 2x times 2 to the power of minus 1 by 2 to the power of 2x, you get what? 2 to the power of minus 1. A lot of you just write the answer without understanding as to what you are doing. Are you following? Yes. Is this what you got? Yes. Who is saying no? Okay. Well, what answer did you get? Someone said no this side. Okay. All right, let me carry on. Then my denominator is 2 to the power of 2x. Therefore these two are going to cancel out. Okay? After they've cancelled out, I'll get 1 minus a half. The denominator here is now a 1. Okay? So my final answer will be what? A half. 1 minus a half gives you a half. Huh? No, it's a positive half. It's not negative half. Listen. What is 2 to the power of minus 1? It's a half. And what is 1 minus a half? It's a half. How many of you got a half as their answer? Right. If you didn't get a half, what answer did you get? No. You can't get negative a half because 1 is greater than a half. You can't get a negative answer there.
And then, sir, if we're going to take out a common factor, which is 2 to the power of 2x, you know?
What? Okay. Please feel free to ask. Feel free to ask. Feel free to ask. What's your question? Yeah. It's 2 to the power of 2x. Wait, it's 2 to the power of 2x times 2 to the power of minus 1.
So you don't keep the negative sign.
Which negative sign?
Negative 1 to the power of a.
I talk about this one here.
Yes.
Okay. This negative sign here, it doesn't affect anything in terms of taking out the common factor. Your common factor, you look at the first term here. Is there another term which is common to it? Yes. But there is a minus here, so we neglect the minus. We take this 2 to the power of 2x. When you take it out, the minus still remains. This minus here is the same as this minus. So here you will have 2 to the power of 2x times 2 to the power of minus 1. If you divide this by your common factor, which is 2 to the power of 2x, these two will what? Will cancel out. And you'll be left with 2 to the power of minus 1. But this minus here remains as is. In fact, okay, let me take you back to a lower grade. If I give you, say, AB minus B, if I ask you to factorize this, what's the common factor? B. Then what's the first step of the binomial factor? Does this minus here change? No, it remains the same. The same concept applies here. The only difference that we now have exponential terms instead of algebraic letters. Yes.
So, sir, what we did is we took out the common factor and then we divided it by the first term.
The first term, yes.
So what we actually did is that we divided it by the second term. For the second term, that's why we divided it.
So you didn't have this one here.
We did not have it. We divided it from the negative to a to the total.
Okay. Now that's a mistake which you made because your numerator is a binomial. It's like this. It's like this. It's a binomial. It's only that if I were to compare this one and that one, I might need to rewrite it as say A minus AB. How do you factorize this? You take out your common factor A, then you end up having 1 here. How do you get the 1? It's A divided by the common factor. Then you divide the second term. Don't worry about the minus. AB divided by the common factor, that will give you what? Minus. Is that clear to everybody?
Yes.
Okay, so let's move on to the next one. I just need to remind you that factorization is a very, very important technique, especially in this grade when it comes to exponents. Okay? Right, let's carry on with that one then. Now, this one, it has got a mathematical technique that you have to apply in order for you to simplify it. Okay, if I were to ask you by observation, do you have a common factor? By observation, do you have a common factor? No. No. You can't have a common factor if this exponent here is not the same as that exponent. It's not the same as that exponent. The exponents are not the same. So how can I make the exponents equal? It means that the first term, which is 3 to the power of 2x, I can write it as 3 to the power of x all squared. Alright. Okay. Please be aware, and I have your attention, please pay attention carefully. Please be aware that 3 to the power of 2x is the same as 3 to the power of 2 all raised to the power of x. And they are both equal to 3 to the power of x all squared. So these three exponential terms, they are equivalent. So depending on the question you have at hand, you need to move from one form to the what? To the other. So for this question, because it requires factorization, since we have got 3 to the power of x here, we have 3 to the power of x here, it will be wiser to create 3 to the power of x there. And the only way you can create the 3 to the power of x is by writing this as 3 to the power of x all squared. This will be minus 3 to the power of x all over 3 to the power of x. Then you also need to be aware that 3 to the power of x all squared is the same as 3 to the power of x times 3 to the power of x. This will be minus 3 to the power of x all over 3x. This is your first time. That's why I'm moving from this step to that step. But as we move forward, you should know that from here straight away, it's the same as that. There is no mark allocated for rewriting 3 to the power of x all squared as 3 to the power of x times 3 to the power of x. So I can skip this step. Right? Are you following there? It's very important to know what I just wrote there. If you want, I can also add this and write this as 3 to the power of x times 3 to the power of x. They are all equivalent. Okay? Then, what's the common factor here? 3 to the power of x. So we get 3 to the power of x times 3 to the power of x minus 1 all over 3 to the power of x. Then, this 3 to the power of x and that 3 to the power of x will cancel out. So your final answer will be 3 to the power of x minus 1. Please be aware. Okay, this is very important. When you write your answer, be very, very careful. This is 3 to the power of x. The x is an exponent. This 1 here is not an exponent, it's an integer. Okay? So when you write the final answer, be very, very careful how you write it down. Okay? Yes.